Transformations, pre-college algebra. Transformations are actually something we've discussed previously in Algebra 2 trigonometry, but not to this extent. So all of this you've actually seen before. Maybe you don't remember it. Like I said, we didn't talk about it a lot, but we briefly touched it a little bit in Algebra 2. But you'll see more of it now in pre-calculus and pre-college math. So these are the transformation properties of f of x. And to get a demo here, let me use my calculator to show you what I'm talking about. If we were to pick just a standard graph you should be familiar with, like say x squared, and the graph of x squared is just a very symmetrical parabola. It's symmetrical on the y-axis. It goes through the point 0, 0. And we're going to call this the parent function, basically what we're starting with. And then a couple of transformations that if I were to take this and at the end of the x squared do plus 3 to it, that shifts the graph up 3. And we see it went from 0, 0 and moved up 3. And if I were to change that to a minus 3, then you can probably guess what's going to happen. It's going to be shifted down 3 from its starting point of 0, 0. What's a little bit interesting is the side to side, that if I were to do x plus 3 squared, now this is different than x squared plus 3, and we often relate it to like inside and outside the parentheses, like the x squared plus 3, that was after the x squared, it's outside the parentheses, but inside the parentheses with it, these are the side to side transformations, and plus actually means left. So the plus 3 means the graph's going to move to the left by 3. And so instead of 0, 0, it's moved over to the left by 3. And the minus would actually go to the right by 3. And so we'll see to the right by 3 over here. Then the ones after that are really the transformations that if I were to do negative x squared, negating the front of it, what that does is it flips it upside down. It reflects over the x-axis. Again, we're familiar with that one. Instead of negating it, like if I were to make it 5x squared, that would make a what we call a vertical stretch. It stretches it vertically, making the graph much more narrow. What makes it flatter is not negating. Negating flips it over the axis. What makes it flatter is less than 1, but still positive. Something like, let me just clear this out. If I were to do like 0.2x squared, so 0.2 is less than 1, but it's still positive, that's what's going to make it a wider graph. So these are all the rules, and it's really just kind of a memorized topic where the plus after the function, the plus after the outside of the parentheses, that means up, where minus means down. The plus inside means left, but the minus means right. Multiplying by the front of it, like 5, or that's going to be a vertical stretch, making it narrow. But if you do less than 1, like the 0.2 I showed, that's going to compress it to make it wider. This is your horizontal stretch and compress. That one's a little bit more difficult. And it's much rarer, so I don't want you to worry about that one as much. Negating the front is going to reflect the x-axis. Negating the inside reflects the y-axis. But again, that's also difficult to explain here, especially on this example. Like what we're saying is instead of doing negative x squared, if we did parentheses negative x parentheses squared, and now this would be reflect the y-axis, but it won't look any different to you than the original because the original is symmetrical on the y-axis. So if I flip this on the y-axis, it looks exactly the same. But again, that's kind of a rare one too. So don't worry too much about the horizontal stretching and the y-axis reflections. What I really want you to remember is that plus minus outside is up down, plus minus inside is left right, where the plus is left and the minus is right. Negating the front's the reflection over the x-axis. That's an important one. And then multiplying the front is either going to be a stretch or a compress, depending on that number. If it's greater than 1, it stretches it, making it narrow. And if it's less than 1, it compresses it, making it flat. So a couple quick questions, and this is typically what these questions will look like. Here's x squared. What happens when I do x plus 2? Well, inside plus is left. So let's just translate left, too. So it's really just remember the rules. How about this one? Minus 3 on the outside means down 3. D. Very simple. All right, so now we're getting a couple of things all at once. Negating the front of it reflects the x-axis. So I'm looking for x-axis reflection. Plus 2. Now the radical here is kind of acting like a parentheses. So instead of parentheses and squaring, it's a radical. So like this plus 2 would be considered inside the radical, and this minus 3 would be considered outside. So this plus 2 is inside. That means, left 2. And this minus 3 outside means down 3. So this is your reflection. So we reflected the x-axis, and then we went left 2 and down 3. So that's what that is. But also a good practice is to, type in the original. What they're saying is simply y equals the square root of x. So if we were to do that, that's second x squared and x. So this is my original graph. And then you could keep that there and use the y2 one and then type in what the new one is. So negative second x squared x plus 2, and then exit the radical and do minus 3. And then take a look. And so I'll see that it is reflected upside down, and it did go left 2 and down 3. So it's helpful. You have a calculator that can compare these pictures. Let's do one more quick one for you. The 2 in the front is a stretch, vertical stretch, not shrink. It's going to make it narrower. The minus inside is to the right 4, and the plus outside is up 6. So that's it. All right, so that's really it, just remembering the properties, and we'll practice this stuff in class. See ya.